guys, today we are going to be looking at, looks like it's a 17, it's a Volvo. It is so XC90, and it was towed in by another shop, and they told me that, I believe from what they told me, is that the vehicle was driving and it, I guess, just stopped all of a sudden, if I remember right. Now, this is one that they approached me with months ago. I told them I wasn't sure if it was something I wanted to dive into, but I was asked again here recent, and I said, sure, why not? Let me have a crack at it. Basically, it is a crank no start. They're thinking, or were thinking, something with timing possibly, but I told them put a brand new battery in it in order for me to look at it, because I know that it's been sitting for months. And so I'm going to start by scanning it and kind of just go from there. Alright, let's see if I can get that annoying noise to turn off, maybe. So this is, it's not your everyday deal. So let's close the door. Alright, as far as trouble codes, let's start with that. Engine computer codes. So looks like we've got 12 of them to start with. So an 11 or a 0117 coolant temp, okay, a 0344 camshaft position sensor circuit, 04, another 034192 camshaft, range random misfire, coolant starter relay, ECM related, crankshaft position correlation. Okay, so crank position, camshaft position. So we've got a 0017. Looks like, so perform incorrect operation. Okay, I can see why they would think there's something going on with timing. And let's see, there's something going on with this coolant temperature sensor ordeal. Fuel. Alright, so won't bore you with too much of the rest, because this clearly is a crank no start. Let me say this, make a report, email it, and then we'll start just doing some physical testing with the scope. Try to get some quick answers to possibly, let's verify if timing is truly out. The way that I'm going to do that is with a simple relative compression test and ignition sync. I'm expecting, if it is out of time, to see the ignition strike not at the peak compression point if we are truly out of time. So let's get set up for that, take that measurement, and see if we get that we are expecting. Alright, so I've got my probe on ignition coil number 1 control. I don't know where the battery is on this vehicle, but there is the fat cables going to the starter, so there's my amp clamp. And just when I was making my connections, I did notice this very convenient purge line, and so I removed it, and I'm going to just for as an added data point, I'm going to tap into the intake right there with my vacuum transducer and get a reading of the intake as well. All right, we are set up. Let's crank it. All right, let's stop the scope. Let's see what we got. So first, let's look at relative compression. Yeah, I'm not sure if you can tell how it sounded. Almost like it wanted to start, like it was hitting. And actually, to my surprise, the ignition strike is happening at a close to a peak point. Not what I was expecting. So what I mean by that is, let's kind of bring this up a little bit more. And so these would be or signify top dead center compression point when the cylinder comes up and builds the highest compression. This red sync is ignition coil number 1 when it should be striking. And, you know, the rule is that for good timing and, you know, engine in known good condition, you want your ignition point strike to be very near and or at the peak point of compression. And we have that. At least what would supposedly be cylinder 1. I mean, I suppose it could be very far off and ignition magically hitting at top dead center of a separate cylinder, but I don't really see it happening at the exact peak point. But anything is possible, so what we have here. So we've got 1, 3, 4, 2 is missing, back to 1. And then you can see 1's level just from this cycle to cycle changes, goes down. So does this one compared to that. This one seemed high and then back down. But again, the engine cranking was very inconsistent and almost seemed like it wanted to hit. But what seems to be consistent is that cylinder 2 seems to be missing. So it's this here, it's this here, it's this here, it's this here. That at least is consistent. Now, if I clean this up, I don't know if it'll help any or if we need to. Might be just easier on the eyes. But yeah, that's what we seem to be getting. And what's weird, if you look at it, so it's 1, 3, 4, missing number 2, 1, 3, 4, missing number 2, 1, 3, 4, and we have 2 come up, or not necessarily come up, build something, and then 1 is there. 3, 4, 2. Okay, no. Let me back off. And this is a good lesson to point out. Not sure if you can pick up from this far off view. The distance here to here, here to here, here to here. This one is different. This one's shorter than this one. And so it's throwing off, I think, our coil activation. So, yeah, it's not really throwing off the activation. We are still striking at peak point there, so that is cylinder 1, 3, 4. So we are still missing 2. It's just sharply missed. It's quicker. This bottom wave is quicker than it was there, than it was there, than it was there, than it was there. That explains and helps signify the reasoning for this portion being closer, this red to this red, compared to here, here, here. And because that's slower crank, and then it sped up, and then so it decreased this bottom wave or loop, and it doesn't look as prominent as that, and it makes you think, like I thought, that that was 2. But it's just, it's sped up, so that's rushed, and then 1 comes in quicker, and then it goes on. But it number 1 is always striking there at the same point of its top dead center. That's crazy. Okay. Just to get you a measurement to show you, kind of prove out. Let's start here to here, and let's lock that in time, and let's move on over. So it's a little off there. Let's get you guys better. So this one already has sped up a little bit compared to that first segment. Looks like this one's going to be sped up also. So that's sped up more. Let's go to the next one. Looks like that one slowed down some. And then this one really sped up. See how far ahead this red trace is compared to that. So that's showing us our very inconsistent, erratic with speed fluctuation cranking event, and so it can make it hard to even look at what is typically a simple waveform, which is a relative compression. But this engine, this cranking, is so up, down, up, down, up, down, as you can tell, just up, down, that our speed fluctuations is continuously changing, and it can make it a little bit difficult. So 2 things we have picked up, or 3 is the speed fluctuation. Number 1 is actually striking at top dead center, and we have lost cylinder number 2. All right, guys. Now we were having so much fun with the relative compression waveform that we totally forgot about the intake. So let's take a look at the intake and analyze that. Here is a faraway view. I've brought down the green channel, which is the intake. I've already filtered it, and I'm going to start off with trying to show you if we look at the blue pattern first. If we look at it kind of in waves. So here, the blue goes up and then kind of comes down to its bottom peakish point, and then it shoots up high, and then it comes down again to a kind of bottom peakish point, and then goes up. The higher it goes, the higher the amperage draw is on the starter. And just to get an idea, let's get a number. So let's pick somewhere in that obvious high peak point right there. Our number in amperage. So let's call that 300 amps of cranking. And then if we come down to down there at the bottom right there is 128. So just over half the difference. And so what I am trying to get at is the higher the blue trace goes, the higher the amperage, but also that means it is slowing our crankshaft speed because it is getting harder and tougher for the starter to continue to rotate and spin because it's fighting resistance, it's fighting compression, it's fighting pressure, and the starter's working harder, so it's slowing the engine rotation down in speed. And then once we shoot down, obviously it's like going downhill. So it's climbing uphill, it's rough, tough, and slow, and then boom, it shoots and it just speeds up the crankshaft. The lower it is, the faster it's gonna spin. Now if you see here, this portion of red and red, that's short compared to the red there. So there's big difference. Now, if you look again from this far off view, and let's see, you see some anomalies in the intake trace pattern, particularly when we get there. So you see that spike there, that spike there. We see differences. Now let's try to explain this. So if we come here to this portion, let's drop down the blue a little bit, and we'll do 2 cycles here. And so let me okay, so we've got, so from our red trace here to here is 1 cycle, from here to here is another cycle. And we want to see 4 pulls and in each cycle. So we've got a pull here, we've got a pull here, we've got a pull here, and we've got a pull here. And there's the end of our cycle. So that's 1, 2, 3, 4 pulls. We have 4 pulls. And then again, in the next cycle, let's check and see. We've got a pull, 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 and pull. So we've got 4 pulls. But something that jumps out clearly is this guy here, this guy here. That's the same portion on each side. Now, I'm not going to nitpick right now this little V that happens at the peak point minus this guy here. Again, V, 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 and nothing there. We're not going to nitpick that right now. We're just going to look at what's a bigger anomaly. And I'm going to explain that. And you have to keep this in mind because this all right now has to do with crankshaft, engine, rotation, speed, changes, and or fluctuations. Don't get it confused with pressure changes due to increase of pressure in the manifold from a leaking valve or bent valve, so on and so forth. If you remember, when we have high point in blue here and here, our crankshaft speed is slowing down. And so once we pulled and then we get over to the next portion of pull, we are slowing the crankshaft speed because we have high amperage, and so it's kind of just going to the right as it goes up, and it's because it's slow, it's going slow, so it's taking longer to get to where we need to be, and we have slowed our trace. And the same here. That's what we are seeing cause that anomaly. It's because our crankshaft cranking is just so terrible that it can lead us down the wrong rabbit hole in the intake. Now, if we do the same and look at the portion where we have this anomaly. And here is cycle to cycle. You can tell it's a little bit shorter, so that means we're faster in time. And we gotta look for our 4 pulls. So we have a pull, and then we slow down, and then we have a pull and have a pull. So let's count the pulls first. 1, 2, 3, and 4, all within between that engine cycle. So this one we're seeing because of the slowdown in that one cylinder that keeps slowing down our crankshaft. But this, we are seeing this deep reach in vacuum is because we accelerated the crankshaft, and so we increased our force and we shot it down further. And that's what we are seeing with this anomaly here in our short portion. And again, it's in the section where we know our speed fluctuated because, let's get rid of that, because it's where that bottom loop in our relative compression was very minimal. So it's this portion here, and there is our missing number 2, but it looks like a V. It doesn't look like this long U. It looks like a V because we've sped up our crankshaft, and our intake trace is being affected because of our speed increase in our crankshaft. So what am I getting at? It's almost, I'm going to call it useless to try to analyze intake unless you can pick out and know the difference when your engine is just cranking so inconsistent and fluctuates so much in speed from high to low that be cautious when taking intake readings, because again, it can lead you, if you're not experienced, and this is why I'm teaching you guys and showing you guys to pay attention to that. And the reasons why those anomalies happen is because of what's going on in the crankshaft speed. Alright guys, so just to see if we can identify if our compression is being lost in the exhaust, I've gone ahead and put a probe in the tailpipe. People usually ask me how I make my connections. It's pretty straightforward. I'm in the tailpipe. Keep in mind, if you've got dual exhaust, like a lot of the Europeans and stuff, one of them might have a let's call it like a check valve to silence the exhaust. So make sure you pick the side that doesn't have the valve, and just stick your probe in there and take a reading. So I want to see if we have any anomalies, basically higher pressure shooting out of the exhaust, to see if that's where our compression loss is at for cylinder number 2. All right. I don't think I'm seeing anything in the exhaust, but we'll double check. All right, so I'm gonna make one last measurement to see if we can find the loss of compression, since we didn't find anything in the exhaust trace either. I'm gonna measure the crankcase. So we'll go ahead and crank and see what we find. Alright, let me stop this and modify it for you guys to understand, but I can already see something. Alright, so we've got relative compression in blue like before, red is ignition trace, and green is going to be our crankcase pressure. So if we clearly see a big spike in pressure rise at that same point. Number 2 is supposed to be, or is traveling up, but we have lost pressure there. But we're finding it in the crankcase. So with that said, obviously definitely, as we were already aware, mechanical damage. We know now it's in the bottom end through the piston, either land or we got a hole in the piston, something. But we're probably going to have the burnt up piston crown. But we can verify that by getting a camera, and then now kind of final dagger, just go in there and visually get a picture of what's going on in cylinder number 2. Alright, so we're getting ready to go inside the cylinder with the camera to try to take a look, see what's going on physically. But one thing we noticed, and these are in order, so 1, 2, 3, 4. If you look at this on 2 and 3 compared to 1 and 4, these coils are shot, they're melted. That's 2. And number 3 as well. So I don't know what's really going on. Obviously that shouldn't be like that. But we'll take a look. And then the other thing, since people usually try to ask where I make my connections, this is where I was tapped in for the crankcase measurement. It's part of the crankcase vent valve assembly. Typically, I would go in the oil cap with just a drilled out port and tap in that way. But I don't have a cap that would fit in there. Again, Volvos usually don't come through here, so I tried here, which was the next best step, and was able to get a good measurement there. So with that, we'll get a shot of what inside the engine looks like and see what we find. Alright, so right now we are purely just going to try to see if we can prove a point based off of what we saw on these coils and on the in-cylinder pictures, where both cylinders 1 and 4 were, compared to these, were dry, or somewhat more dry than these. These clearly were not firing at all, and cylinders were wet. So we are going to put 2 coils in 2 and 3, we're going to assume that we're going to have spark out of all of them now. And also to prove a point that based off of the relative compression where cylinder 1 was striking at the top dead center point, and maybe it is in time, and for some reason it's just not fully hitting on all cylinders from what we see. So we're going to just install these, see if it will start, crank and idle. We know that we're going to be on at least 3 cylinders, but in my mind, we have had plenty of vehicles that come in with this situation, and it's simply just a misfire, not a crank no start. So we want to see if we can at least get it running. All right, so we're going to give it a shot here, see what happens. Yeah, it's right there. A little bit, not a lot. It runs, it just has a miss. It's no smoke, it's just a lot of raw fuel from that cylinder. You can see smoke coming out of the cap.
Turn it off or leave it on still?